Welcome to ML Maker tutorial session. In today's session, we will see how to build a text classification model using H2O.ai. Text classification is a process of assigning category or tag to a text or a paragraph according to its content. Some examples of its applications are sentiment analysis, topic labeling, spam detection, etc. Text is a extremely rich source of information, but extracting insight is a harder job, mainly due to its unstructured nature and semantic and syntactic complexity of language. We will see how to leverage NLP techniques to solve this problem. In today's exercise, we will build a spam classifier using a publicly available SMS content dataset. Let's first import the required H2O library. I've used H2O word to vec estimator and H2O gradient boosting estimator. Then let's import the spam.csv data. The data has two columns, category and message. Let's preview the data. Yeah. So first task is to tokenize the SMS text, split into words, and do some basic cleanup. So I have done the stop word removal. So H2O frame.tokenize, what it does is it will split the words in the text into single column separated, each sentence is separated by an NA. In general, machine learning algorithms are not capable of processing string in their raw form. So we have to use a technique called word embedding. So word embedding is a language modeling of feature learning technique where words or phrases are converted into a real number vector. In simple terms, text are converted to a number representation. So there are two ways, two high level categories of word embedding. First is frequency based embedding like count vector, TF, IDF vector. So here, based on the frequency of each word, the text or the sentence is converted into a numerical representation. Next category is example is word to vec. So word to vec was developed by Google by Thomas McCall. It uses neural network to learn weights, which acts as the word numerical representation of the word. So the advantage of word to vec is it also uses the based on the context in which the word appears. So thus the words which have similar meaning end up having similar numerical representation. Let's create a word to vec using H2O API. So I'll use estimator, create an object of it, and on that invoke dot train, pass on the tokenized word list. So this will create a word to vec model. So word to vec model also provides a find underscore synonym word function. So if you pass on a word, it will give out in this data set the synonym or word with similar meaning. So customer representation service arrive. So these are the words with similar context. So next is we have found the numerical representation of word, but how to arrive or derive the numerical representation of the SMS sentence. So for that, invoke dot transform method on the word to vec model and use aggregate underscore method equal to average. So what it does is for each word in the sentence or sequence is mapped to a vector. So the words within the sentence are averaged out and the word to vec or numerical representation of the whole sentence is derived. So let me execute that. So word to vec is finally it's a vector of size 100 elements. Okay, so this will act as your predictor variable. Okay, so now the predictor variables are ready. So to create a training data set, you would need the target variable. So let's see how to add up that. So we'll remove if there are any NA columns and just do a C bind, that is column wise bind the category column. So once that is done, then you split the data into training and validation. Okay, let's preview the final data. So this will be the final data which we'll be using for classification model, for building the classification model. Okay, so the data is ready. So now it is same as the process is same as how we build a classification model. Your data is ready. Now you just create an instance of any classification model. So here I'm using gradient boosting estimator, call invoke dot train, and in the X pass the name of the predictor variables. So here SMS vector dot. So I'm using all the word to vec column names, that C1 to C100, and Y equal to category, and pass on the training frame and validation frame. So once the model is trained, we'll see how to build or predict category for the new SMS content. So here uh, a predict method is defined. So it has SMS content, word to vec model, which was created for the training data, and the classification model instance. So when once you pass on the new SMS content, you have to do the same pre-processing which was done for the training data. So that is first convert into tokens, and then using the list of tokens, create the word to vec representation of the SMS, new SMS. So for that, you just use the word to vec model dot transform and aggregate underscore method equal to average. And once you get the vector representation, call gbm.predict, pass the test data, the vector representation of the model. So let's predict what is the category for these two SMS. First is hi, meet you at 10 a.m. and second SMS, free offer, get a cash reward of $10,000. So let me execute it. Yeah, wonderful. It has given an accurate prediction. So the first SMS, hi, meet you at 10 a.m. It predicts not a spam. And for the second SMS, it predicts spam. So we have come to the end of the tutorial. Hope this tutorial gave you an idea of how the text classification is done. Have a wonderful day. Thank you.